SQL Server and Couchbase are fundamentally different in their approach to data management. Sort of. Let's take a look at how the differences between tables and documents are, to some degree, all in how you look at them. All competitive posturing aside, the core design approach of relational data management systems is brilliant. Normalization across tables can minimize total data footprint while still supporting maximum flexible ad hoc use of the data. Further, due to the enforced data schema, long-term structural predictability is assured, which can be critical for systems of record that may carry heavy procedural or even legal implications. All that being said, planned denormalization has become widespread in response to the exponentially expanding data floods now pouring into business systems. Denormalized data is fast to read and more easily mapped to code, potentially directly matching a target object model. In-memory joins are minimized, supporting highly elastic, massively scalable architectures. Further, the schematic flexibility in this approach allows data models to evolve as quickly as a rapidly evolving market-facing codebase. As a result, coding itself, which can be the most expensive and risk-prone aspect of any project, can be simplified. Let's start by looking at the top-level containers used in each approach. In relational systems, that's a database. In Couchbase, it's a bucket. Now, a bucket is an unstructured document container, perhaps more easily thought of as a key space, because the hard physical limits are intentionally few. Document keys must be unique, and the maximum document size is 20 megabytes. In a database, values are structured within tables. In Couchbase, they are most commonly structured within JSON documents. Just as a table row represents an individual record, documents are commonly designed to represent a single record. So then what's the equivalent of a column? Well, like-named fields within documents can be directly analogized to a column, though with some interesting possibilities. The same field name could be used across documents of different types, opening interesting new possibilities for flexible data access. This notion, in turn, opens up the common design pattern of assigning an explicit type to each document. Do so, and a set of documents sharing the same type become, for many purposes, the functional equivalent of a table. Would it make sense to create another table for another entity of some form? Well, create a new type of document. But always remember that each document is potentially different. This flexibility opens a whole world of rapid development possibilities for systems engaging with rapidly evolving inputs and aggregations from many different systems. Because your schema is defined by the data structures your code reads and needs, not the system into which it writes. So then, why would you ever have more than one bucket? Well, you can have up to 10 in any given cluster. But there's no firm need to align buckets with applications the way you might with a database. Instead, buckets serve as the boundaries for different concerns. They're the level at which you define varying caching, replication, indexing, and security needs. They're also a useful boundary for meeting multi-tenancy requirements. SQL Server creates its core structures, database and table, directly in SQL, using the create database and create table statements. In Couchbase, buckets can be defined on the command line, using the Couchbase CLI tool. Documents themselves are created either by code or data loading. SQL Server can bulk load data to tables using its BCP utility or bulk insert statement. Couchbase supports a powerful high-speed command line tool called CB import for bulk loading data from either static or piped sources in CSV or JSON formats. It includes useful features to, for example, dynamically generate document keys based on values in each document being loaded. Or if you prefer a visual approach, buckets can also be defined via the Couchbase UI, which itself is just a well-designed skin for interacting with Couchbase's comprehensive REST API for administrative operations. Virtually anything you do or see in our web UI can also be securely accessed via REST API. Enough with the slides for a minute. Let's jump in and take a look at how easy it is to create and load a bucket. What I'm going to load in this case is 5,000 JSON documents, each one expressed as a single line within this file on my file system. Each of these documents is shaped like this. It has a username, it's got an embedded type as well. But also notice that it has this nested billing address object. I point this out because this isn't quite the same as just a flat record of scalar values within a table. It's multidimensional. Now, when you would embed data like this versus reference it in a separate document is a topic we get into in our free online data modeling course and elsewhere in documentation and blog articles. It's a really interesting topic, data modeling in JSON. For now, we'll just keep moving. I just wanted you to notice that here. Now, I don't have a Customer 360 bucket yet here in my Couchbase instance. Now, I could come in and create it here visually through the UI, give it a name, a memory quota, select the type, and go in and set other things like how many replicas and so on. But you learn more about all of this in another course or in the documentation. Here I'm going to do it all from the command line to show that approach and keep it simple. So out on my file system, I have this Customer 360 data.json file, but I also have an individual file, the first record, saved out as a file on the file system also. Notice the file name. It has the document type customer prefixed to some unique value within the document. That is the pattern that we want to use as a key pattern for each document inside the bucket. Now, exactly why you would do this and put document type information in a document key is discussed further in our data modeling course. Just notice the pattern for the moment. I'm going to use the Couchbase CLI tool to create a bucket called Customer 360 of the Couchbase type with this much RAM allocated on my local cluster using these credentials. My bucket's been created, so now I'll use the CB import tool. I'm importing JSON, not CSV data in this case, into my local cluster using these credentials into the Customer 360 bucket we just created from this file locally on the file system, which is formatted with individual lines. And in the documentation, you'd see there's lots of different ways to use the CB import tool. This is just one. But note that I'm having it generate a key for each document based on the type and the username embedded in each document. Here we go. There's 5,000 documents imported. Note, I didn't edit the video there. Yes, that's how fast we got 5,000 documents in. It's a very fast tool. So we now have a Customer 360 bucket inside of Couchbase with 5,000 documents. And I can jump in here and open up the first document. And there we have it. We have the document we saw out in the file on the file system in the individual document. And it's been given a key based on the pattern that we specified. In the next lesson, we'll jump in and take a look at how to begin indexing and querying this data. So what have we learned? We reviewed how the normalization-focused approach of relational systems avoids redundancy and enforces data schema, while denormalization speeds read access while providing schematic flexibility. We also compared relational and document database approaches, seeing that a single document is similar to a row, commonly named fields across documents are similar to a column, sets of like-typed documents are similar to a table, but the documents can evolve and change as quickly as your code. We also saw that buckets are containers for uniquely keyed documents up to 20 megabytes each that provide your control boundary for caching, replication, security, and indexing behaviors, while also providing you support for multi-tenancy requirements. Next up, we'll introduce indexing and look at how basic SQL and nickel query operations compare. Stick around for that, or go ahead and jump into the labs now. No one knows better how you learn best than you.